Welcome back. This is 8.1 Sampling, Frequency, Distributions, and Graphs. So our objectives we're describing the population whose properties are to be analyzed, select an appropriate sampling technique, organize and present data, and identify deceptions in visual displays of data. So, some statistics definitions. So, statistics is the method of collecting, organizing, analyzing, and interpreting data, as well as drawing conclusions based on the data. Methodology is divided into two main areas: descriptive statistics and inferential statistics. So, that's a mouthful. And then you can read those. All right, populations and samples. So population is the set containing all the people or objects whose properties are to be described and analyzed by the data collector. Sample is your subset or subgroup of your population. I'm having a hard time saying words today. Representative sample is a sample that exhibits characteristics typical of those possessed by the target population. All right, example 1, it says the Board of Supervisors in a large city decides to conduct a survey among citizens of the city to determine their opinions about restricting land use in order to protect the environment. So you're going to describe the population. And then B, a supervisor suggests obtaining a sample by surveying people who hike along one of the city's nature trails. Each person will be asked to express his or her opinion on land use restriction to protect the environment. Does this seem like a good idea? So you're describing the population. So our population is the set of citizens. The set of all citizens. So the set of all the citizens of the city. So that has to be for your whole data collection. That would be, you have to give each citizen an equal opportunity to take the survey. So B, so since that supervisor suggests that you only survey people who are hiking, it wouldn't be a great idea. So the subset of hikers would be likely to have more of a positive attitude about environmental issues since they're already out in the environment, and they would favor the land use restriction. And that wouldn't be an equal opportunity to represent all your citizens. So it wouldn't represent all citizens, and the hikers would favor the land use restriction. So you want to, when you're doing your description of your samples and your data collection, you just want to kind of summarize what your thought is for that. All right. Random sampling. So random sample is a sample obtained in such a way that every element in the population has an equal chance of being selected for the sample. And then your methodology is to identify each element in the population, assign numbers to each element in the population, and then randomly select numbers. Then you would assign the elements in the population who have those numbers to the sample set. So, example 2. So we return to the Board of Supervisors in the large city and their interest in how the city's citizens feel about restricting land use in order to protect the environment. Which of the following would be the most appropriate way to select a random sample? So it says randomly randomly survey construction workers who live in the city. So obviously that wouldn't represent the whole population. It would only represent the construction workers. So, and those construction workers depend on new construction. So they would be, they wouldn't like the restriction of the land use because they want to open up more land to do construction on. So you would say the sample does not represent each citizen. And does not give an equal chance. Because in your samples, you want to have people that are for and against so you can see where that data may fall. All right, the next one, it says to survey the first 200 people whose name appear in the city's telephone directory. So, same again, it only covers those first 200 people. It doesn't give the opportunity for every citizen to be selected. So you would say, does not give each citizen an equal chance to be selected. All right, and then randomly selecting neighborhoods of the city, and then randomly survey people within the selected neighborhoods. So this would be an example of that random selection because you're randomly selecting the city, so you're not favoring one or the other, and then you're randomly selecting citizens within that neighborhood. So still not being favoring a population of people. So yes, it would give each citizen an equal opportunity to be selected. And as long as you have like the main idea, I think most of these will be multiple choice where you're selecting the right choice. So make sure you're reading those and make sure you're looking at those carefully when you're making your selections. All right, frequency distribution. So it says a piece of data is called a data item, and then collected data can be presenting using a frequency distribution. Such a distribution consists of two columns. The data values are listed in one column, and then numerical data are generally listed in the smallest to largest. So the adjacent column is labeled frequency and indicates the number of times each value occur. All right, so constructing a frequency distribution. So it says construct a frequency distribution for the data of the age of maximum yearly growth for 35 boys. So you're looking at the lowest number to highest number. So if you look through each of these, so it looks like 10 is the lowest. Like if you look through like each row of those, like 12 would be smaller, 10 would be smaller here. And then 11. So it looks like 10 would be your smallest. And then your largest, so you'd go through and do the same thing. You see which is going to be your largest. So in this row, 17, 18, 16, and 15. So 18 is going to be your largest. And then you want to find out how many times that those occurred. So, oh, that is not an eraser. So for these, you would go through, so for 10, you would go through each one and it only occurs the one time. 11. So 11. So twice. 12. 1, 2, 3, 4, 5. And then you would repeat that to make your table. So, and then you would add up this column, and that's your total. So right there's the total. So n is equals to 35. If that number doesn't match your original population amount, go back and see if you missed a number anywhere. So then it says, what are some conclusions we can draw from this example? So it looks like the maximum growth, so the more amount that we have is from 12 to 15. So notice how it gets bigger and then it starts to get smaller again. So growth from 12 to 15. And then you would look and see, oh, maybe what is the maximum year that has the most growth? So you'd say max growth was at age 14. And then you could say minimum growth would be like 10, and then 17 and 18. So they just start to grow, and then they stop growing around 16. All right, example 4. So here are the statistics test scores for a class of 40 students. Group the frequencies into classes that are meaningful for the data. Since letter grades are given based on 10-point ranges, use the classes 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. So you want to see how many you have in each of those groups. So at 40 to 49, so 47, and then you're just looking through each row, 45, 43, so that's 3. Because this would be 40 to 49, 50 to 59, 60, 80 to 89, and 90 to 99. All right, then 5, so 1, 2, 3, 4, 5, 6. All right, and then 60 to 69, so 1, 2, 3, 4, 5. Well, there should be one more, 6. And then 70 to 79, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 80 to 89, it should get easier as you're like crossing off numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the last one, let's see, we'll do it in gray. So 1, 2, 3, 4, and it should be the ones that you have left, 5. All right, and then you want to add up your total. So 3 plus 6 plus 6 plus 11 plus 9 plus 5 is going to be 40. So then you want to look at kind of what that would mean. So your lowest scores were from 40 to 49. Your highest scores, there was only 5. And then the most, so you could say maybe that's your average, is from 70 to 79, because that's your most. You could maybe draw that conclusion. And then you had equal, so like these would be equal. So it just depends on what you're looking for in the data and what kind of conclusions you're wanting to draw from the data that you get. All right, histograms and frequency polygrams. So histogram is a bar graph with bars that touch, can be used to visually display the data. A frequency polygon is a line graph formed by connecting the dots at the midpoint of the top of each bar in your histogram. So notice that it's like in the middle of each of those. It would make kind of a triangular shape. All right, stem and leaf plots. This plot is constructed by separating each data item into 2 parts. So stem consists of the 10 digits, and your leaf consists of the unit digits. So like we had before, your scores. So from 40 to 49, like in your leaf plot, you would do 4. And then you would do your numbers. So those were in black here. So we have 43, 45, 47. So we would have 3, 5, and 7. So this would be your stem and leaf. All right, so it says use the data below for a stem and leaf plot. So we're looking at all of these numbers here and then making our stem and leaf. So kind of like we just looked at, it's the same data that we just had. So our 4s, so that 47, so 47, 45, 43. All right, so you can go in order or from least to greatest. It doesn't matter. So you could do your 7, 5, 4. Just to keep it in order. So 47, 45, 43. So then 5. So we have 57, 54, 56, 7, 50, and 59. So for this one, so 7, 4, 6, 7, 5, 0, and 9. So in order of the numbers as it appears. So go ahead and finish out the rest of that leaf plot, and then you can go ahead and come back and check your answers. All right, so this is what you should have gotten for your leaves. And you'll notice, like if we did like a graph, if we turned it, our graph would kind of go like this. So it kind of makes that triangular shape. And notice most all of the points kind of are around that 7 value. So remember 70 to 79 was our highest for the test scores, the most amount of people scored within that range. So that would be your data, your highest point in your data. All right, deceptions in visual displays of data. So graphs can be used to distort the underlying data. So you could have like a high point and a low point, which maybe is not represented. So the graph on the left stretches the scale on the vertical axis to create the impression of rapidly increasing poverty rate. So notice how it's increased. So right here, your y-axis is stretched a little bit. And then notice on this other one, it kind of looks like a flat curve, because if you do like your normal y-axis, it's more like a flat curve. So the graph on the right compresses the scale on the vertical axis to create the impression of slowly increasing poverty rate. So it can skew your data based off of how it's represented. So just be careful when you're looking at graphs and you look at all of that's represented. All right, things to watch for in visual displays of data. Is there a title that explains what's being displayed? Are numbers lined up with tick marks on the vertical axis that clearly indicate the scale? Has the scale been varied to create a more or less dramatic impression than shown by actual data? Do too many design and cosmetic effects draw attention from or distort the data? So is it too colorful, too many images, and kind of stuff like that? How has the wrong impression been created about how the data are changing because equally spaced time intervals are not used on the horizontal axis? Furthermore, has a time interval been chosen that allows the data to be interpreted in various ways? Are bar sizes scaled proportionally in terms of the data that they represent? And is there a source that indicates where the data is in the display came from? Do the data come from an entire population or a sample? Was a random sample used? And if so, are there possible differences between what is displayed in the graph and what is occurring in the entire population? So we'll discuss more about margins of error in section 8.4, so don't worry about that too much here. So who is presenting the visual display, and does that person have a special case to make for or against the trend shown by the graph? So kind of like if a construction workers union was sampled for saving land property. So they would be against it because they want to keep building and have that job security. So you just want to see, is it skewed in any way that doesn't represent the whole population? So here are some examples of misleading visual displays. So just be careful when you're looking at these. So see how they make the dollar really big and then 43 cents really small. Well, 43 cents is it's close to like half a dollar. So they should be more equally spaced out. And then examples, this other example, so number of square feet in an average U.S. single family home. So notice how it made it like 3 times larger with the shadow. So you just have to look at that and see, are they skewing it in a way to make you interpret the data in a certain way? So just be careful when you're looking at your data. All right, if you have any questions, please let me know. Otherwise, work on your assignment.